Bonjour. On peut parler français. No, it's a joke. It's a joke. I want to talk about software development today. Software development with JavaScript. You hear me? It's fine with my. Okay. I didn't test my presentation, so if I'm running out of time, please give me a sign how many minutes left. Would be nice. So I can accelerate and at some points maybe. My name is Ilja Franke. I'm working since 1993 in the company, which was named not Axians IT Solutions before, but never mind. Now it's Axians IT Solutions, and yeah, I was developing with C++ and all that stuff in the old times. Nowadays I'm developing with JavaScript. And that's what I'm talking about today. First, what we do. We are a department within IT solutions, developing software products. Just not software writing, but it's writing software you can sell, so it's software product development. And the main focus is data center automation. Since 10 years nowadays. The main product is named DPCM. It's an acronym for Power Cloud Manager. What means Power? Power is an IBM hardware platform, a special platform which is not Intel based. And the product is automation software for this specific platform. I have a separate session tomorrow. Who's interested? What is DPCM? What is Power? I will explain in this session. In a short explanation, what does this software? It means it is a sort of standardization. It has an easy UI the admin can use. It's fast, and because it's fast and automated, it's at the end cheaper to operate a data center on this platform than do it manually at the end. Yeah, we have history in this software. The very first version was introduced in 2011 as an easy tool to operate a private cloud. In these days, we don't speak about public clouds, but the people don't want to go in the public cloud, so they talk about a private cloud. A private cloud means that there are several departments. They need virtual machines, and the aim of the software was to deploy those virtual machines easily. In the following years, we had many customer needs. We had functional enhancements in the software, and we have growing data center sizes. We started with little data centers consisting maybe of 2 systems, running maybe 10 virtual machines, and then we got customers where really hundreds of virtual machines are controlled by the software. We started then, as we go further in the development, that we have to change something. Our software base wasn't like so that we can fulfill all the needs the customer has and to fulfill the performance issues we have in those great data centers. And we decided to redesign the software completely. So no old code will remain in the new version. So we found a word for it. It's our nickname for this version. It's the version Snow Goose, and not only a version number, because we redesigned it really completely. For the redesign, we have to talk first about how is the software created for the version 1. It was maybe a classical approach we do all in those days. It's 100% open source. It's in the front end, it's an Ajax communication to the server based on Dojo as framework. We have in the back end an Apache server for HTTP, Tomcat. So the back end is Java based, and MySQL, classic stack. And in the back end too, KSA scripts which talk actually to the back end, to the servers, to the components of the data center. When we decided to redesign this the software completely, we are talking not also about the back end issues we need, but also what do we need, what does a customer, what does the person which uses the software needs. And we think it must be a fast UI, it must have a useful user experience, an outstanding user experience if we are happy at the end. It should be a fancy UI, it should be blinking and it should be graphical. But more important is if any customer comes with new functionality, we can realize this functionality very fast in the software, and we don't have edges where it's really difficult to expand or extend the software. The next point is, we heard it today, we really need an API because we don't know what the customer really at the end want to do, and if we can do it for himself with an API, this would be really nice at the end. And last but not least, national language support. What do we need on development side to fulfill all those requirements for the user or for the customer? We want to have really fast development. Where we don't run into some edges, and one point of this is HMR. I will show it later what does it mean. It's short hot module reloading, so you code and you see directly the result of this coding. We need in the team a short learning curve. It's difficult if the language is complicated or it's a big framework where it's difficult to do something. So new persons should be able to work very fast with this environment. Also, we need a CI process. CI means continuous integration, so that we can code and start something and then it will be deployed. We want to have supported the usually used developer tools and time-saving helpers. Sometimes, if you look in a Java environment, there's sometimes you haven't such support that you really want, because it's sometimes a little bit outdated. We need ready-made open source modules to reduce our efforts, which we may have to create a software. And the most important is that those used open source modules are really maintained actively, that it's not old and maybe committed 8 years ago, and there are no security updates and stuff like that. So we decided to rewrite the software completely on JavaScript. It's also 100% open source. We have an UI front end which is based on React mainly, and we have a back end with node.js. Node.js is also JavaScript, so the main issue here is that you really can code from the client to the back end with one language. There's no language switch in between. I added here some icons. It's a React icon and Bootstrap and GraphQL and Nginx and Node, and this is maybe what we have in the front end. In the back end, also OpenScript based on Postgres and Influx and Docker for our environment. Sometimes I get the question, why do we choose JavaScript? Why don't you use Go, or why don't you still code in Java? If you have a look, there's a really great community in JavaScript nowadays. I have integrated here a video. It's questions on Stack Overflow over the years concerning by language, and we see there's really a growing interest in JavaScript, and people are working with it. One more reason, maybe this statistic from GitHub. I think it's the commits. I'm not quite sure what statistic I found, but also you see over the time development to JavaScript. Nowadays, TypeScript is rapidly growing, but TypeScript is also JavaScript if you want. So it's another discussion maybe. So, what we detected as needs for the user interface, it's all starting with the layout. We know that it's mostly not sufficient to take some template from somewhere and then creating your application. From my perspective, is really needful to talk with an agency which is used to create UIs, and you discuss the needs you have in this interface. And if you have this layout, you have to create this layout. You want to have a responsive layout. Sometimes people misunderstand responsive as fast. Responsive means that you have adapted to the screen, the accurate screen size is if it's an iPad or even a phone, that your application is working independently of this of the screen size. This means responsive, and a standard framework for the style sheets is also very useful, because you don't invent the wheel again and have many problems you have to solve across the different browsers. We want to minimize the client-server communication. The most expensive part of an application is the communication itself to the client, because by expensiveness in needs of time, because it always takes time to get data from the server. So, and we want a fast loading client, which means that we have minimized code. We identified socket communication as a major part for this. Socket communication means there's a separate kind of communication between the client and the server. I will get to this point later. We need ready-made UI widgets. You don't want to create every time you build a new dialog, oh, I'm missing a slider, or oh, I'm missing this and that. This must be ready to use. Then more meta on this point is that we need a standard approach for authentication. and for functional changes. If you think in part of authentication, it means this user with this role has a right to do this and that function, and your application should adapt to this rights this specific user has at the end. At the end, also national language support I added as an essential part for UI. So I talked about React. What is React? To explain React, maybe I go back to the classical approach how an application, a web application, talks with the server. So there's a client. You have a browser open, type in the URL, and this is requested. The HTML is maybe generated on the server or simply delivered as static file and sent to the client. Maybe in this client or in this HTML file, there's again a link to a JavaScript file which must be loaded again, so that we have two round-robin actions here. Then this JavaScript is executed, and maybe in this time again a communication to the server will get some data and integrate it into the application. Then there are some links, and the links makes that there are requests to the server, and all is going around. And in this point, I found this distracted boyfriend being the best for this. This is the client, and he's talking to the server, which is a little bit disappearing, and the user is angry because he's waiting. So in the React approach, is like that the client can request an URL, and the server sends a nearly empty page. It's only containing the body and nothing else but a bundle, a JavaScript bundle, which is started and which builds the HTML on the client. So the HTML is not built on the server, it's built on the client. And the main point there is that you have a client-side router. So if you type in an URL or you have an URL link, then there is no round robin to the server. Again, the HTML for this link is built on the client again. Then still we have AJAX requests to the server, but with React you get the possibility to change the DOM tree in this HTML code, specifically at this points where you get new data. So the answer, what is React? Maybe it's a library to build up and change DOM tree upon state changes. So there's one name you can put in this React ecosystem called Flux. Flux is an architectural approach from Facebook, how to create states within an application and how to interact with the DOM tree. And we use Redux. Redux is a concept built upon Flux, where we have at the end, if you want, in this application only one variable holding all the state of the application. React does the work of state handling, of avoiding race conditions, and on coding side we have a so-called JSX, which means that you can nearly code HTML as you want, inject JavaScript elements into this HTML, and so it's very easy to handle it. The main point why we choose also React is we don't need any special HTML variables inside. So this is the main difference to Angular maybe, that you can take the HTML you created for the first representation of a layout and then build up this thing with JSX without using any special HTML attributes which were put together with the framework. I have a little demo here. What is the difference? When I started, you will see the following. This is our old version 1, login. Then I switch to a page and switch to another page. And then I log in a new version and switches also the pages. Here's an open debugger where you see the network request flowing, and I hope it's starting. Let's see. Okay, that's now the new version. So after login, I switched between 2 pages, and you see it's only one page where network requests flowing. They are sometimes in parallel, so there are many requests for getting such data here, working in parallel. And compared to the first version, where we have switching to the first page, there were, I think, 100 requests getting images and all that stuff. Bootstrap, I talked about Bootstrap 2. It's a library to build up responsive mobile-first web projects. Very useful from my perspective. There's a grid system. There are input and display components which are ready-made, a layout of this ready-made. And you can achieve a global styling with SAS variables. It's a kind of pre-compiled things you can put into your CSS at the end. I have some screenshots. The first maybe of DPCM, the system view. You see some graphics, and we have here performance data of 1 day. Graphically integrated. This is the point where we have this influx database request, and which drawing this graphics. Here, overview over all running virtual machines with a performance mini graph if you want. We can open details and search. Here's all demo VMs or virtual machines, and some details with many tabs where you can go down in the details of this virtual machine. I won't go into this further because tomorrow I have the chance to show DPCM in detail. It was just to have a look and feel how this software looks like. This was a part for the client side. We have also needs for the backend services at the end. We want to have a scalable architecture, which means think about, we're talking about this influx database. It might be a big difference if we collect over 10 machines data, 10 virtual machines or hundreds. And if it should work at the end, that we have graphics where we can zoom in and there's no delay or waiting for the data, we need to scale, to be able to scale our software. For coding, it's important for us to have it non-blocking. We have thread-safe code. Don't run into any deadlocks. We have to look why is there a deadlock. One more part is API documentation. If we identify that the customer need is to have an API, we need a documentation for that API. And during development, we constantly change the API. So we need something how we can document the API for this version. Again, we need a standard approach for authentication, API usage, role assignment, token handling, and socket securing. I didn't mention it in my presentation, but we rely on JSON Web Token. So it's a token system where this authentication is done, and also we need this for the API because we don't want to have token which fades away in 10 minutes. We want to have a token which is stable, but we can control. For the socket communication is the same, because sockets at the first point have no authentication system, so we have to build an authentication system for the socket communication. Also, a big part is logging, error handling. Think about an application. You want that if any user uses a function and the function runs into an error and he's calling, there's an error, you want to see in the log which error he got, what was happening. The next is the error handling itself. Think about language support. That's not useful if this error is at the end in English and you don't understand English. So you want to have this error in the national language the client is operating. So the server must know, oh, there's a client talking German, so I must translate this error message to the client. And the next big point is process management. Think about actions you have in an application which are long running, maybe for an hour. You start something and it's running for an hour. You want to have a ready-made system where you can create such processes and then interact in the client with this process. Calling an API and waiting 1 hour is not a good idea. You run into a network error and you don't know what is happening. We decided for the backend to use node.js, as I told before. So, what is node.js? It's server-side JavaScript. It's like coding JavaScript in the client, but on the server. It's based on the Chrome V8 engine, and we get non-blocking I/O with this with Node.js, and an asynchronous flow, and on top build up package management. So we can. Package management means that you can say, okay, I want to use this and that module, and this package is loaded from internet, integrated into your coding flow, and you can maintain these packages with versions and so on. This means package management, and then we can use such things like Express. It's ready-made library to create HTML or HTTP requests, socket I/O for the sockets I mentioned, passport, ecosystem for authentication against Active Directory, LDAP, and so on. We have also support for Redis, key value store, or Massive, which is the code name for Postgres requests at the end, and many more. Actually, we're using around about 200 or 250 modules in the software. GraphQL. We decided to build up the API with GraphQL. GraphQL is a query language for APIs. So you can think about it as a schema-based REST API at the end, but it's not REST as we know it normally, because really you have to define your requests or queries or mutations in the language of GraphQL, and you define the arguments and the results, and you describe those arguments, what are they for. So at the end, because GraphQL can a so-called introspection, you can ask the client itself, give me your documentation for your API, and then you get what you get at the end is some self-documented automatic API documentation, and we have it integrated in our client, so you can go in if you have the right for this API and see which queries you can request the server, and what do you need for this request.
10 minutes.
Okay, why sockets are useful? As you know, browsers are a sort of connectionless connection. Server request something from the server, you get the answer, and then there's nothing. Sometimes you want to send from the server something to the client, to this client, not to that, but to this client. And therefore, the sockets are very useful, and you can create this. But we need for this an authentication layer. I have a demo for this. What you will see is we have two clients. One is maybe in Aix-en-Provence and one is in Ulm. And here is a user. The user wants to change his account settings, the name and mail address, something like that. And here's an administrator working with the users. And he wants to change something at this user side, and he opens the user to change something and go for a coffee. And then have a look. This is the user opening the account. This is now the admin going to edit this user. He switches maybe here the page. Then the user don't like it to be yelled Franke. You want to be named Franke. He changes number because it's wrong. And you want to use another email address. And then he changes the account, and immediately the changes are on the client in the open dialog. And if you ask, if someone had, if this administrator has changed here the name, then this will be not updated. And this is what you can achieve with sockets, so it's very useful to get a really shiny UI where it's always up-to-date data the user sees. Some words for our workbench. We're working with IntelliJ, integrated linting, Predia. Linting, does anybody know what is linting? Okay. Versioning Git, code quality Sonar, which is very useful. Open source for JavaScript. It's there are no payments need, and you see here in the on the bottom maybe one screenshot from Sonar where you see we have many code smells. Then we do something, then there are no code smells, and then we try to create some more functionality, then there are code smells, and then again there's an iteration to get rid of this quality issues. At the end, deployment with Jenkins as quality gate for testing, for minimizing the build and the deploy process at the end. Before we created a new version of DPCM, we created this framework to build DPCM. So this is quite of trade-off. We have at the end an application template. You can clone this template. You have to configure parts and stuff like this, and then you can create your application. So what do we get out of this framework? We have a development ecosystem. We have the app, the client itself, an administration client, and an UI backend server. We have integrated authentication, the API documentation, our ecosystem, widgets, error handling, the mobile app with Bootstrap, the admin client, and the backend. So what does mean ecosystem? We rely on webpack, so all this hot module reloading, minimizing of code, bundling, usage of Babel is already made. I talked about this HML. What is this? So here I add something to display the company name, and then I want a telephone number in this visit card there. I hit on store, and then it's automatically rebuilt, and we see the result. So it's very easy to create your UI because you don't have to restart something and so on. You can simply work. While we have an administration client, it's ready to go. The UI for the configuration of Active Directory, SMTP, the roles, capabilities which can this role do at the end in the application, user management, specific settings. The main reason why we do this in a separate client is that we can create an individual UI for the application itself, so this is at the end separated. The build process, what means minification at the end, you see in the case of DPCM, really small files at the end. The application itself, it's empty, but you have the navigation, user credentials, this account settings, all that stuff. It's ready made, and you can start coding. Some samples, what we do with this framework. One was the Axians portfolio radar, where there's very different navigation, which is more graphical, drill down in this data. We created some more projects with it. One was the Omexen project prototype. It was a prototype fulfilling a workflow about 3 different user roles, and then a document was in this workflow going around. It was about 4 days to create this application with the framework. There's some things more I cannot show today because I'm running out of time, I think. One is with the DPCM operations. It's a portal for our own, for license management and which data, which version, which customer has, and so on.